Hi everyone, I am Manoj Gopale and this is my final video presentation for the topic Verilog Suite, a design framework for circuit design and verification for the course ECE 505 Model Integrated Computing taken by Professor Dr. Jonathan Sprinkle. A Verilog Suite will help a user to efficiently design a hardware. It will also reduce the time taken for designing and verifying a circuit. A user has to previously know hardware description languages like Verilog and VHDL to write Verilog and test benches. This is used by Verilog compilers to convert into a waveform-like interface where you check the design for various inputs. A Verilog suite will remove the dependency of a user to know hardware description languages like Verilog and VHDL to effectively use compiling tools to validate his or her design. So let's say we have a circuit as shown in the left. So a user can replicate this circuit in the Verilog suite and get an output a test bench and a Verilog file which he can use in the available compiler tools to validate the design. So these two files were taken into Vivado Xilinx tool for validation of the design, and I have a snapshot of one of the waveforms that you get after you run the code. Coming to the tool itself, in this I have two different frameworks. One is the Verilog suite where you can design tools and then write out a Verilog file out of that. Second is you can create a test bench and write out a test bench from it. To start off, if you have to create a circuit, you will have to create a child of the Verilog drawing. In Verilog drawing, you can drag and drop components from the left hand side as such. You can have inputs, AND gate, and OR gate, outputs, and to connect these you will have to just drag and drop from inputs from one component to the next component. I have a full adder circuit that I have previously drawn. In this plugin you can see that I have a Verilog connection check which connects the connectivity of the circuit. There are three major connectivity issues that can be seen in a circuit. One is you have dangling wires where you have nets that are not connected to anything. Second is you have created a net but you have not named it. And the third is you have multiple nets coming from the same gate but which don't have the same names. So before writing out a Verilog file, you must always check for Verilog connectivity check. To write out a Verilog file, you just click on the create Verilog button, save and run. This will create an artifact Verilog folder zip file which you can download by clicking as such. This will create a Verilog code that can be used directly in the compiler tools for validating your design. But only a Verilog code is not sufficient to validate your design. You also need a test bench which consists of multiple test cases you want your design to be tested for. To create a test bench, you create a child of test bench drawing. In this you will have a component known as module name and states. So module name is the name of the circuit which you want your test bench to test for. A module can have multiple inputs and multiple outputs. A state consists of the input values for which you want your design to be tested at a particular instance of time. So let's say I have a previously drawn a full adder test bench. In here you can see I have defined all the inputs here on the right hand side and the outputs. If I go inside a state, I will see that I have the inputs and what values I have instantiated for. So basically a test bench is where you test your circuit for certain values at a particular instance of time. So in here I have used only 4 test cases, but you can have multiple test cases for which you can test your circuit for. Similarly, similar to Verilog, connectivity check, I have a test bench connection check for the test bench suite, in which it checks for any connectivity errors in the circuit. Like you cannot have multiple connections from one state to another state. Once your design is clean, you can create test bench by clicking on the create test bench plugin button. It will create an artifact known as testbench.v, which you can directly download. You can see that a full adder test bench has been created, and there are 4 cases for which I am testing my design against. So this file, along with the Verilog file that was generated, can be directly input to the available compiler tools to test your design against. So this was just a small example, but if you have a circuit as complex as this, you will surely need to check for the connectivity errors in the design, and you can generate an Verilog by directly clicking on create Verilog here. If you have multiple circuits like circuit 2, circuit 3 that you want to test against, so this suite is very useful in creating a single test bench file that can test for all the circuits. So I have test all circuits created previously. So in here I have circuit 3, circuit 2 and circuit 1, and these are the test cases for which I will be writing my test bench for. So let's say you create a test bench. So it will create testbench.v. If you open this file, you can see that there are 3 circuits that are defined: circuit 1, circuit 3 and circuit 2, and I have multiple checks, multiple values for which I am checking the circuit against at different intervals of time. So this tool can be used when you have to create test benches for multiple number of modules, and it can also reduce the design time for writing out a Verilog once you have a circuit in mind. That's all for this presentation. Thank you for listening. Have a nice day.